Welcome to today's math lesson. It's 4.11. We are going to be talking about multiplication strategies. This is just a review. We're not going to learn anything new today as we wrap up this unit to prepare for the test. So we're just going to kind of go over all the different things that we have learned about in this unit and put it all together in this 4.11. So you'll need a green and a yellow, and you need to push pause on the video until you get your journal set up like this. Okay, you should have written 98 times 15. So what we're going to do first here is we're going to try the place value sections to see if you remember how to do that. So go ahead and write place value sections. And if you remember this, we draw a box and we split it into however many digits we're multiplying. So for example, 98 times 15 is a 2 by 2. And so we draw a 2 by 2 rectangle. Let's go ahead and draw that rectangle green. And we're going to split it. Remember, you don't quite go all the way in the middle. You come off to the side. And now you write the numbers 98 times 15. You break them up into their place values. So we go like this. Well, 98 is 90 and 8. And 15 is a 10 and a 5, right? You break it up into the tens and the ones place. So in this column, we're going to be multiplying to find the area of each little square. So let's color in yellow the square or the rectangle. It's not a square. The rectangle that we're working on to find that area. So if I want to find just the area of this yellow square, what are the measurements that I would multiply by? 90 and 10. So you write 90 times 10, which we're not going to have to write because that's mental math. 9 times 1 is a 9, and then it has 2 zeros, so it's 900. Go ahead and write 900 in the box. All right, color the next box we're working on. Let's go down. Let's do the one that's going down. Color it yellow. And 8 times 10 is 80. Why did I do 8 times 10? Because it's going left and up. So here's an example. I do 8 times 10 because it's going over and down if I want to find that measurement. 8 times 10 is 80. Write 80 in the box. Let's go up to the top, right corner. Color it yellow. How do I find the area of this box? Well, however tall that is, which is 90, and however wide it is, which is 5. So 90 times 5? 90 times 5. Well, 9 times 5 is 45, and then there's a 0. So it's 450. And the last little box. Now we have to find this last little white box. Go ahead and just leave it white. It's 8 times 5 because we're timesing the ones by the ones. The ones by the ones. 8 times 5 is 40. So you write 40 in the box. And now I add all of these partial products together. Do you remember that? Hopefully you do. Okay. I'm just going to add straight across. You could technically add down, but I'm just going to add like this. So 900 and 450, well, 900 plus 400 is 1000, 1100, 1200, 1300. So it's 1350. I write that off to the side. And I'm going to add that to the partial product of whatever 80 plus 40 is. 80 plus 40, well, 80 plus 20 is 100, and 20 more would be 120. So I add that together. Did you get 1,470? That's the correct answer, so go ahead and circle it. That is how you do place value sections. So really quickly, let's come over to the side and write how we did that with some bullet points. We broke up the numbers into place values. And then we multiplied to find each area. We'll say to find the area of each box. Next, we added all the partial products together. That is how you do place value sections. That's it. Let's move on to another strategy. We're not going to do all the strategies, but another one that I think is good to review is expanded notation. So slide your journal down and write expanded notation. Will you box the word expanded notation in green? I guess it's words because it's more than one. Does anyone remember what to do with expanded notation? You can always look back in our journal notes. I think this would have been from lesson maybe 4.2 or 3, somewhere in there, maybe 4.4, probably 4.3 if I had to guess. But anyway, let's go ahead and solve another problem. So we're going to write the problem off to the side. It's going to be 66 times 75. I'm going to write it diagonally. That's what we're working on, is 66 times 75. So if you remember this, we're breaking up the numbers into place values again, but we just write them kind of in a line. So I'll show you the first one. 66 breaks up into 60 and 6. So you write them pretty big. Do you remember this? And what does 75 break up into? 70 and 5. You write it underneath it in the correct place values. So it looks like that. 60 and 70, 6 and 5. How many of you are remembering what this looks like? Okay, well let's use our two colors. Let's use green and yellow in order to have this make a little more sense as we go along. So the first thing we're going to do is we're going to start in the bottom left. Technically, you could start in the bottom right. It really doesn't matter which section that you start in. I think what we did, I think we're just going to start in the bottom right. It doesn't actually matter. So I'm going to take my pencil. If I go like this and I start on 5, I'm just going to put a little dot on 5, a green dot. And I go up to 6, I'm going to draw an arrow to 6. I'm multiplying the ones places together right here. And what is 5 times 6? It's 30. So I write that partial product over to the side. Then I have to times the 5 back in the ones place by the 60. I have to go over into the tens place. And 5 times 60, well 5 times 6 is 30, and then I have another 0, so it's 300. Make sure when you write numbers to add that they line up correctly. And now I'm done with the 5. I've times 5 by the ones place and the tens place. Now I need to go over into the 70 and times 70 by the ones place and the tens place. So what would I times 70 by to get to the ones place? Let's use yellow. Put a yellow dot on 70. Go over to the ones place. 70 times 6. Well, 7 times 6 is 42 with a 0, so write 420. And I did 70 times the ones place. Now I need to do 70 by the tens place. Go straight up. 70 times 60, it's going to be a pretty big number. 7 times 6 is 42, but now you have 2 zeros. So it's 4,200. My partial products went from greatest to smallest, just technically because of the way I did this. It won't always be that way. But I think we may have learned it the other way where we started with 70 and went up and across, and that's fine too. You're going to get the same answers, the partial products, just in a different order. I think it's actually smarter, though, to start in the bottom right corner because that's how we start with multiplication and go up and diagonal. Up and diagonal. Kind of helps. Anyway, you add the partial products together. And let's see what we get. Did you get 4,950? Circle your final answer if you did. Let's write some quick steps. I'm going to write these really quickly, bullet points. Separate the numbers. Multiply them up and diagonal. We'll say the bottom numbers. Multiply the bottom numbers up and diagonal. We'll just kind of show what that looks like with the green. Up and diagonal. And then with the yellow, it looked like up and diagonal. What do we do after we multiplied all of those? We added all the partial products together. We're just going to say add the partial products. So that's expanded notation. Let's try another one since we have some space. We won't write all the steps again, but we have some space down below. Let's try 59 times 28. So I'm going to write it diagonally. So separate the numbers. Write them really big. Pick up your green and start in the right-hand corner. Multiply up into the ones place and then diagonal into the tens. 8 times 9 is 72. And 8 times 50, well, 8 times 5 is 40. And then another 0 is 400. You could, right now, if you wanted, you could have said that it's 472. You can kind of combine in your head if you want, because 400 plus 72 is 472. But it's okay if you don't want to do it that way. Now I move over and I do the yellow. So I start in the bottom and I go, and I'm going to go up and diagonal. You can do it how we did it before where we went diagonal and then up. It doesn't actually matter. In fact, maybe we should do that. Let's do 20 times 9 first. Well, 2 times 9 is 18, and then there's a 0, so it's 180. And 20 times 50, well, 2 times 5 is 10, and then there's 2 more zeros. So there's 2 zeros at the end, and then it's a 10. So what is it? 1,000. And the next step, add the partial products. There's no decimals. The final answer is 1,652. Go ahead and circle it. And turn your page. The next thing we want to practice is, there's a couple different methods. We don't need to practice the standard algorithm yet. Let's move on to decimals. Okay, so let's write multiplication with decimals. We're going to underline this in yellow. So an example of a decimal problem might be 0.34 times 12. Remember, when you're multiplying decimals, you do not stack up the decimals. The very first thing you do is make sure the longer one is on top. So let's go ahead and write our bullet points right now. Longer number on top. Decimal box. Deal with zeros. Remember, once you cross out a bunch of zeros or drop them down into the answer, you may have to rewrite the problem so the longer one is on top. Let's go ahead and put that in there in parentheses. So underneath deal with zeros, right, you may need to rewrite the problem. So the longer number is on top. And you might be thinking, well, we already said that. Yeah, but once you cross out zeros, the size of numbers could change. So that's why you want to do that. Let's put those parentheses in yellow. And I'm going to also underline it. Let's go ahead and take care of those 3 steps right now. So right now, 0.34 is the longer number because it has 3 digits. So it's on top, and that's good. We need to draw a decimal box. Will you make that decimal box green? What number goes in that decimal box? It's a 2. Do you know why it's a 2? It's because in the number 0.34, locate the decimal and go to the end of the number to the right. How many place values are there after the decimal? If you said there were 2, you're right. So I've drawn the decimal box. Now I deal with the zeros. Remember, if they're out in front, they're a runt, and you get to cross them out. If they're at the end, they're a friend, and you have to drop them into your answer. If they're in the middle, they're stuck and tight as a fiddle. Remember that? So take your green and look at that 0. It's out in front, it's a runt, cross it out. Do I need to rewrite the problem? I'm now on the last bullet point. No, because it's a 2-digit by a 2-digit. It's almost like I'm saying it's 34 times 12 now, and then I'm going to place that decimal back in, which really is going to be timesing it by 100th because it's 2 place values. Think about that for a minute. So I just do normal multiplication now. So add that to your bullet point on the right-hand side. Write multiply using the standard algorithm. Standard algorithm means that I'm going to have some partial products, but I have to use a 0 for place value. You'll see what I mean in a minute. So go ahead and multiply right now. 2 times 4 is 8. So I write the 8. 2 times 3 is 6. Remember, I'm moving now to the tens place. And now there's no more numbers to multiply the 2 by. So I'm moving on into the next place value. So I have to put a 0, the hero, underneath the 8 because I moved on to the next place value. I'm done with the 2. And now I move on to the 1s. And 1 is going to multiply by the 1s place and then by the 10s place. In this case, it looks like it's the 1s and the 10s because I took out the decimal. 1 times 4 is 4, and 1 times 3 is 3. So my partial products are 68 and 340. We add them together. This This is all part of the standard algorithm. If you got 408, you're correct. But are you correct? Oh. How can it be 408? I was supposed to be taking a piece of 12. It's not correct yet. Draw an arrow from the decimal box. Dun, dun, dun. We better add that over in our steps on the right. So we multiplied using the standard algorithm. Then, next bullet point, we're going to say use the decimal box. And we'll draw an arrow in that. Kind of show what it looks like. All right, we bring it down into our answer. So it can't be 408. Go back up to the answer. Move it 2 times. It's at the end of the number right now after the 8. So if I move it 2 times to the left, it becomes 4.08. Ta-da! That could be a piece of 12. That makes more sense. So use the decimal box. And then we'll say circle your final answer. If it was really messy because you did little loop-de-loops to get the decimal to move, if it is messy, then you may need to rewrite it. So we won't write that, but make sure you remember that. Okay, let's circle our final answer in green. And let's try another one. The next one we're going to try is 0.58 times 40. First step, longer number on top. It is. Second step, decimal box. A 2 goes in that decimal box and make it green. Deal with zeros. There's a 0 out in front in 0.58. It's a runt. There's a 0 at the end of 40. It's our friend. We're going to bring it down into our answer. Do you remember that? So bring it down here. And now I need to see if I need to rewrite it. 0.58 is longer than 4 because I've taken all these other things out. So I can just multiply. It's like saying 58 times 4. So I start in the 4th place and I go clear over to the 8. 4 times 8 is 32. So I drop the 2 and carry the 3. And then 4 times 5 is 20. But I have to add the little 3. So it's 23. The answer can't be 2,320. The step we're on is to use the decimal box. So draw the arrow down. Right now it's 2320, but I need to move it 2 places to the left. It becomes 23 and 20 hundredths, or 23.2, right? You could kind of say that either way. I would accept either answer, but you need to recognize that it could be 23.2, and it could also just be 23.20. All right, we're going to try one more because I know we love decimal multiplication. We're going to try it up here a little bit to the right. The number is 1.34 times 0.8. Is the longer number on top right now? Yes. Draw a decimal box. Make it green. What number goes in that decimal box? Well, there's 2 decimals. There's 2 place values after the first number, like 1.34. So that's 2 on the top number and 1 place in the bottom number. So 2 and 1 make 3. It's a 3 in the decimal box. Write it. And now do the standard algorithm. It's like, oh no, sorry. Now deal with zeros. There's a 0 out in front. That's awesome. It's a runt. Now do the standard algorithm. It's like saying 134 times 8. You should be able to multiply this on your own. Could the answer be 1072? No, that's not a piece of a piece. We're talking about a piece of 1. Literally. It can't be very big. So this is why the decimal box is handy. Draw in a green arrow and move it 3 times. How many of you can see where it would go? Moving it 3 times places it in between the 1 and the 0. So could 1.072 be a piece of 1.34? Yeah, makes sense. That is just a review with decimal multiplication. I don't want you to try the other strategies with decimals. I think they can get a little confusing. But if you're just timesing whole numbers, you can do any of the strategies we've learned. You could do place value sections, place value boxes or rows, expanded notation, standard algorithm. But when it comes to decimals, I want you just to stick to, what is it called? Standard algorithm. Okay, the last thing we're going to review with is powers of 10. We should probably review estimation too, so I'm sorry. It's not the last thing. It's close to the last thing. Powers of 10. That's another thing we got to review. So let's go ahead and draw a yellow separation line in between what we just did. So the rest of this journal page I'm going to use for powers of 10. Okay, I'm going to write it over here to the far left. Powers of 10. And I'll put that in a yellow box. Okay, so now we're focused on powers of 10. We're going to do bullet points again, so be ready for that. Maybe we'll put the bullet points on the left this time. The first bullet point. To multiply by 10 means 10 times bigger, right? So numbers are shifting to the left. Technically, each digit is moving to the next higher place value. So to multiply by, we'll just say 10, 100, 1,000, etc. Multiply by 10, 100, 1,000, etc. is making each digit shift into higher place values. What's the trick for that? Do you remember? The trick is that you can just move the decimal the opposite direction instead of shifting all the numbers. So we're just going to write that in parentheses. Trick. Move the decimal to the right. And use 0 the hero. Actually, you're going to need to use multiple of them. So, and use 0 the heroes for placeholders. That is the trick. Will you put that trick in green parentheses? The trick is to move the decimal to the right and use 0 the heroes for placeholders. Instead of shifting all the numbers to the left, we just move the decimal to the right, and it's a lot easier. And how many times do I know? The exponent tells you how many times to move. So let's put that as a bullet point. The exponent tells you how many times to move. Okay, let's practice a couple. over here on the right hand side, I'm going to write 4.7 times 10 to the first. Remember, you just say 10 to the first means 10 to the little 1 exponent equals what? Well, remember, if I'm timesing something by 10 to the first, what that means is 10. So I am going to be shifting the numbers. Both of those numbers are going to shift into higher place values, or I could just do the trick. I look at the exponent, and I go, oh, it's a 1. I'm supposed to move all of the digits 1 time. So I'm just going to move the decimal 1 time. Will you take your green and make the little 1 green? And then I'm going to show that movement with green to the right. The decimal would come after the 7, so it would be 47. That makes sense. The 4 used to be in the ones place, but it got 10 times bigger. And now what place is it in? The tens. The 7 used to be in the tenths place, but then it got 10 times bigger, and that bumped it to the ones place. So that's how it works. Pretty cool. All right, try 4.7 times 10 to the second. Make the little 2 green, or you could circle it. I'm going to circle it, it's a little easier. And move the decimal 2 times. You can't move it 2 times. There's only one place to move it, so what do? Yeah, you use 0 the hero. Will you use your yellow for that? So if I had a 0 there, I could move it one more time. So it would be 470 decimal. I don't need the decimal at the end of a number like that. All of those numbers shifted 2 places to the left, or they got not 20 times bigger. How much bigger did they get? 100. 10 to the second is 100 times bigger. Think about it. If I had $4 bills and then I said, because they're in the ones place, 4 ones, and I said, oh no, that gets to be 100 times greater. What is 4 100 times greater? 400. And the 4 is in the hundreds, so it's super cool. I love powers of 10. And why don't you try 4.7 times 10 to the third on your own? Make it green, the little 3. Did you get 4,700? You should have. Look at the pattern that's happening. Let's go ahead and make a little bubble off to the side here, a little bracket that says this is a pattern. Just write pattern. There's a pattern happening there. It's pretty awesome. This time I'm only going to use pencil, okay, because I think the colors can get a little confusing with how bubbly they are. So let's try another one. Let's try this. 0.16 times something equaled 16. It says again, 0.16 times something equals 16. So I'm trying to figure out what did I multiply it by to get to 16? Oh, the digits are the same, just 1 and 6. And it definitely got bigger, so it has to be a power of 10. How many times did I move the decimal to get it to be at the end of the 6? 2. Will you show that with your pencil? So the exponent has to be a 2, or 10 to the second. Okay, well, what is 0.16 times 10 to the third? What does that equal? Got to move it 3 times. So who holds that empty place value? A 0 does. Fly it in. And I bet you could do the last one, 0.16 times 10 to the fourth, just by looking at the pattern. Will you please write it? 0.16 times 10 to the fourth. And solve it simply by looking at the pattern. It went from 16 to 160 to 1,600. Did you get that correct? I hope so. When we meet in the next video, you will need to have found in your workbook, oh, we didn't practice rounding. Never mind. I'll see you in the next video.